Bonjour, mon nom est Marius Prédan, enseignant-chercheur dans le département Artemis de l'école, et j'ai le plaisir de vous présenter le Master Virtual and Augmented Reality. Comme le Master est en anglais et ouvert à l'international, je vais faire cette présentation en anglais. The Virtual and Augmented Reality Master 2 program aims at providing the students with the fundamental background and technical skills necessary for developing innovative industrial applications, as well as cutting-edge research programs in the field of virtual and augmented reality technologies. It is an M2 of Institut Polytechnique de Paris, and it replaces or is in complement to the third year for the TSP students. The composition of the master program is the following. It is organized in 3 periods. Each period has 5 weeks, as following. In the first period, called the yellow period, there will be 3 modules: basic computer vision, computer graphics, and human-computer interaction. In the second period, the blue period, there are also 3 modules: advanced computer vision, artificial intelligence, and social robotics. Finally, the last period, called green period, covers virtual reality, augmented reality, and collaborative environments. As well, during the entire period of the master, covering the 3 periods, there is a transversal project program. Let's now have a look on the content for each module. The first one, Basic Computer Vision, sets the foundations of computer vision for augmented reality, with emphasis on matching and 3D pose estimation issues in a single camera framework. Methods for camera modeling and calibration, image and video processing and analysis, scene understanding are introduced, enable the students to tackle and solve 3 use cases: marker tracking, natural feature tracking by detection, and incremental tracking across consecutive image frames. The computer vision-oriented open source library, OpenCV, will be presented and extensively used for experimenting these technologies and implementing effective solutions. The second module of the yellow period is computer graphics. This module will introduce various 3D representation models and algorithms for virtual environments, from geometry primitives, texture mapping, animation and deformation, to rendering and lighting algorithms. This module will also detail various approaches for virtual character representation and animation. The third and the last module of the yellow period, Human-Computer Interface, will address the design of human-computer interfaces from 2 perspectives: software, advanced visual programming, toolboxes, web interfaces, and human factors, user-centric design, evaluation, and ergonomics. This module will also address natural user interfaces, more specifically gesture and mobile interaction paradigm. We move now to the blue period. The first module is a continuation of the computer vision one, is called Advanced Computer Vision and 3D Reconstruction, and has as an objective to describe various techniques for 3D object reconstructions, like point clouds and meshes, by using different sensors, from LiDAR to color and color plus depth image. The blue period also has an artificial intelligence module that introduces various AI techniques currently used for context understanding in virtual reality and augmented reality application. A particular focus is put on deep learning approaches that have achieved in recent years a spectacular breakthrough in the field of object recognition and scene understanding. You will be able to understand and create machine learning models, as well as use them for real cases. The third module of the blue period is called Social Robotics. It will introduce several methods and algorithms used in robotics for human user modeling, like gesture and posture classifications and modeling, automatic and incremental learning of different concepts and tasks, signal processing for verbal and paraverbal communication in human-robotic interaction. Finally, in the green period, we also have 3 modules. The first one is augmented reality, that address the fundamentals of augmented reality systems and applications, starting from natural and synthetic content aggregation and moving to spatial and temporal registration, object tracking, advanced rendering. You will be able to practice various tools for creating and managing interaction in augmented reality. The second module of the green period is virtual reality, that is addressing the fundamentals of virtual reality systems and applications, from sensors to scene modeling, interaction, up to immersive rendering. You will be able to practice several tools for creating and managing interaction in such virtual environments. Finally, a module dedicated to collaborative environments will allow you to first analyze, define, and evaluate the basic properties of such environments, and secondly, to review and practice the basic concepts of tracking paradigms for interaction and content. Finally, you will be able to experiment different examples of collaborative environments. Additionally to the 9 modules described previously, and active for the entire duration of the master program, there is a transversal master project. It is self-proposed project. It means that the themes are proposed by the students, and it is performed in group of 2. I finished my presentation with a snapshot of all the teachers involved in the master. I'm coordinating this master with Professor Tito Zaharia, and you have here other professors from different schools that are coordinating or that are contributing to different modules as I presented.